Hi, this is me 180949 presenting you the MES lab final code and simulation here. I am basically using SPI communication between the two microcontrollers for this purpose. Now moving towards the code, here we have some basic include files and some functions. Now we are defining the pins for SPI communication for the master. Basically this code is for the master. Defining the MOSI serial clock and slave select pin. Here I'm using some declaring some functions for our bot, whether it should left turn or turn right turn. This is the stop function and this is the forward function. They are explained later down. In this, we are in the int main. We are using the ADCLM35, which is used to display the temperature on the LCD screen. Here we are using the DDRB pin and selecting the MOSI serial clock and slave select as high because we are sending data. Here we are enabling the SPI master. Now I'm initializing the ports for the communication. DDRJ as output and DDRA and H as input. These basically is not for the LM35. It's for the IR sensors because we are sending output from J and taking input from A and H. I'll show you in the Proteus. Now in this loop we are using the LM35 for temperature display. Int count is equal to 0 and character value is equal to 0, and DDRC is 0 cross 0 0 because we are making the port C as input. Here I'm using the code which is basically somewhat similar to the code we have done in the lab. Starting from here, we are enabling all the parameters for conversion because we need to convert the values from analog to digital and display it on LCD. ADCSRA is basically we have to start the conversion, so we are getting this pin high. Here we have a while loop so that it uh, it will wait until the data is converted. Afterwards, the flag is cleared and this shows the converted output value. This is basically a formula. Now we are using unsigned character D and storing a value in it. Now the I2A function is used to basically convert the integer to ASCII code because we have to convert it in ASCII to display. Now for the IR sensors and the bot, that functions are already mentioned above. We are calling function here. In this we are enabling the slave device low so that we can send data to it and a delay of 1 second. Now this while loop is this condition is true until the data is completely transferred, and when it is completely transferred the slave device will be turned off because the whole data is transferred. Now the while left turn function is called, in which I have used the ports of A and H. Basically the port A is used for the left and right motors and H is for the center motor. I am using two different ports because we have if we use the same port for both for all the three inputs, we have to use each pin and define each pin. So I'm using the whole port as for the center and whole port for the left and right. Pin A 0 cross 01, that means the first pin is high and pin H is high. That means our left sensor and the center sensor is on. Then we are defining what to do. Port J, port J, we are using the AND function. We are getting this low, and for this we are using OR function to get high. So the fifth pin of port is high, so that the robot will turn left. This basically high pin means that the right motor of the robot will move, because the 3 and 4 pins are connected to the left motor and 5 and 6 are to the right. So the 3 and 4 motor will turn off and 5 as high, and the negative terminal is, and then 6 terminal will act as a negative terminal. Now the right turn function here, we are using pin A 0 cross 02. That means the second bit of A, pin port A is high and pin H is high. So the robot will have to turn right, so it will have to off the right motor and only turn the left motor, so the robot will turn right. Here we are using this third pin as high, so that the bot will move to the right by using the left tire, and all these other values are turned 0. Here we have the stopping function. If all the ports are high, so that the robot will turn off. Now the forward function is when there is no input from the left or right, 0 cross 0 0. That means no input from the left and right, only the center one is high, so that the third and fifth terminal is high and 4 and 6 is off, because the left motor has terminals 3 and 4, so they will act as a positive and negative, and the other two of the right will act as positive and negative. Now moving towards the slave, here we have the LCD function, LCD header file that is called here, and we have defining the meso pin. Meso is actually master in slave out, so we have taking input from the master and the slave is making an output. Now we are defining ports as high, because we are using slave as only for output. DDR C, A and D, these all three are getting initializing as high for the output. Now DDRB, here we have the meso pin. First we have to turn the meso high for the output. SPCR is a SPI slave function. We are enabling the SPI slave. Now unsigned character data is called in the LCD function down below. Here we have the data is equal to SPDR. The SPDR is the data controlling register. So whatever the data is taking from the master, the slave use this SPDR to take to get this output and display it into the LCD. Here we have a while loop. It will turn on if until the data is transferred. Now the LCD data, in data means we are sending data to the LCD. Now moving towards the Proteus simulation. Here I am using the IR sensor as buttons and taking these left and right output at A as defined earlier, and the middle one is at H. These are the SPI protocols. As I mentioned earlier, that I am using SPI protocol for the communication between the two microcontrollers. Slave select, se- serial clock, Mosey and Mizo. That is here, and this is our motor driver we are using. So the four inputs here are being taken in as from the microcontroller at port J. Now the right one is connected. Now the right one is the output pins that are connected to left motor 1, 2 and right motor 1, 2, both the terminals. And here we are using 5 volts that is being fed into the motor driver to operate it. Here is the LM35 which is used for the display of temperature, and here is we are using the obstacle detector as a button. If we press the button, that means some obstacle is here, and its output is connected to PD0. That is the we I have connected the PD0, connected it to PD0 because we know that PD0 is the interrupt pin. So whenever it is pressed, the whole code will stop and only the interrupt code will run. LM35 output is connected to PC0. Now moving towards the slave, here we are defining the pins for LCD, RS, RW, and enable, and these are the data ports. Now I'll upload the code here. Here you can see that only the center one is high, so that both the motors will turn on. Now if I press the left with the center, you can see that the left motor is now slowing down and the only the right one is moving, so that the bot will move, take a turn to the left. And if I use this, the center and right, you can see that the left motor is now moving and the right one is getting slower. But if I turned on all the buttons, you can see that all the motors will stop. Now here we are getting information from the LM35, but I don't know why he's sending some garbage value to the LCD. And same is the case with the obstacle. I'm using this obstacle. I know all the theory, but I don't know why it is not working, because I didn't either code this one, but I have coded this one, but still I'm not getting the output. Now moving towards some flow chart. Here I have a flow chart. Start. If all the sensors are on, yes, then the bot will stop. If no, it will check the left and center is on. If yes, then it will turn left by using the right motor. If left and center is not on, it will check the right and center. If the right and center is on, the robot will turn right using the left motor. If this is not, only the center is on, yes, so the bot will move forward. Here is the obstacle detection. If the obstacle is detected, the bot will stop, and if no, it will move according to the sensor information. And for the LM35, if the LM35 is on, yes, so that it displays data on the LCD, and if it is off, it displays nothing. So here I have the complete info about all my code and simulation. Thank you.